Hey everyone, and welcome back to Let's Talk About Data. And today we're diving into the exciting world of Exploratory Data Analysis, or EDA. EDA as your data's first date. It's where you get to know your data, find out what makes it tick, and uncover those hidden stories. We'll be using Python to explore, visualize, and understand our data. So, let's put on our detective hats and get started. On Let's Talk About Data, today we'll cover why EDA is absolutely essential, how to calculate and interpret descriptive statistics, creating powerful data visualizations like histograms, scatter plots, and box plots. And, as always, we'll work through some practical examples. First, why is EDA so important? Well, it's like a first impression. It helps us identify patterns and trends, detect outliers, generate hypotheses, and inform feature engineering. In short, it's about getting a feel for your data before diving into modeling. Let's start with descriptive statistics. These are measures that summarize the main features of a dataset. We're talking about mean, median, mode, and standard deviation. We can use Pandas to calculate these statistics easily. For example, df.mean, df.median, df.mode, and df.std. The mean tells us the average value, the median tells us the middle value, the mode tells us the most frequent value, and the standard deviation tells us how spread out the data is. Understanding these helps us get a sense of our data's central tendency and variability. Now, let's move on to data visualization. Histograms are great for visualizing the distribution of a single variable. We can create histograms using plt.hist from Matplotlib or sns.histplot from Seaborn. They show us how frequently different values occur in our data. Scatter plots are used to visualize the relationship between two numerical variables. We can create scatter plots using plt.scatter or sns.scatterplot. They help us see if there's a correlation or trend between variables. Box plots are great for visualizing the distribution of a variable and identifying outliers. We can create box plots using plt.boxplots or sns.boxplots. They show us the median, quartiles, and potential outliers. Let's put everything together with a practical example. I'll walk you through loading a dataset, calculating descriptive statistics, and creating visualizations. I've provided the dataset in code in the description below. Follow along with me here on Let's Talk About Data, and you'll be able to perform EDA on your own datasets. First, let's import the necessary libraries and load the iris dataset, which contains flower measurements for 3 species, Setosa, Versicolor, and Virginica. The describe function gives us key statistics, mean, median, min, max, and standard deviation. This helps us understand the overall spread of the data. Now, let's create a histogram to see how sepal length is distributed across the dataset. The histogram shows that most flowers have a sepal length between 5 and 6 centimeters, following a roughly normal distribution. The Kday equals true option adds a smooth density curve, making it easier to spot patterns. Next, let's use a scatter plot to check the relationship between sepal length and width. We'll also color code the species. We see 3 distinct clusters, meaning each species has unique characteristics. There's also a slight negative correlation. As sepal length increases, sepal width decreases slightly. Now, let's visualize petal length with a box plot to identify outliers and variation across species. Each box represents the interquartile range, IQR, where the middle 50% of data points lie. The line inside the box is the median. and dots outside the whiskers are outliers. Notice how Setosa has smaller petal lengths, while Virginica has a wider range. EDA helps uncover patterns, correlations, and outliers before jumping into machine learning. Don't forget to like this video, subscribe to Let's Talk About Data, and share it with your friends. In the next video, we'll dive into the world of machine learning. See you then!